So today we are going to talk about 17. We are going to talk about proofs involving angles. And look at this. You don't even have to write anything down because it's all typed out for you. Okay. We have a lot of the same things happening. So we still have our properties of equality. And we still have our properties of congruence. But now our properties of congruence, we're going to use more with angles. Like angle A is congruent to angle A. Okay, instead of segments being congruent. Okay. So we still have the reflexive, symmetric, and transitive property. Okay. But now specifically for angles, we still have the definition of congruence. Okay. But with angles, okay, here's how we write the measure of our angles. So if we're talking about the measure, if we're talking about the actual like numeric value of the angle, we put the M in front of the angle and we use an equal sign. Okay. If the measures are the same, then we know the angles are congruent. Okay. So we can go back and forth with the definition of congruence. Are you okay with that, Nora? Okay. We know that an angle bisector cuts our angle in half into two equal parts. So if it says, hey, this is an angle bisector, oh, then I know that these two angles are congruent, or these two angles have the same measure. Okay. We know that complementary and supplementary mean that our two angles add up to either 90 or 180, depending on which one we're talking about. Okay. So if it says, hey, your angles are complementary, then we can say, oh, okay, these two angles add up to be 90 degrees. Okay. Or supplementary to 180. I don't know how much we've talked about the symbol for perpendicular. This cute little symbol means perpendicular. Okay. And if I'm saying that we have perpendicular lines, then we know the definition of perpendicular means we have right angles. Okay. And then if we have any information about a right angle, the definition of a right angle is that your angle is 90 degrees. Okay. So with angles, we have more definitions to work with. I'm pretty sure with the segments, we had midpoints and congruence, and that was it. Okay. Now we have supplementary and complementary. We have perpendicular. We have right angles. Okay. Now something that is similar to segments is that we do have the angle addition postulate. So we know that two angles. So like angle ABD plus angle DBC equals the whole thing ABC. Okay. So we're going to have that same thing where this small angle plus this small angle equals the whole thing. Okay. Okay. So here are some theorems we can use to help us. Okay. Vertical angles are congruent. Okay. I'm not going to make a big deal about these. Okay. Don't cross them out, but you're probably not going to use them. We're probably just going to use them in a different way by not actually like calling those a name. Okay. Well, let me back up a little bit. I want you to circle this right here. If we have a linear pair, we know that they're going to be supplementary. Okay. That's something that we are going to use. Okay. And then these two here at the bottom, we're not going to use. Okay. we're gonna just use logic to power through any of those concepts that we need. Okay. But if we have a right angle and we have two forms that make a right angle, then we know they're gonna be complementary. Okay. I don't know if we need to really officially go through all that, but there that is. So anything on this page could be one of the reasons we use for one of our proofs. Okay. I think the biggest thing with these angle proofs, the biggest difference is we have more theorems, more definitions that we could pull from in order to make our angle proof work out the way we want it to. So there's going to be more types of problems that we see. Okay. So go ahead and turn the page and we're going to look at this proof right here. Okay. Okay. So we know that PQR is a right angle. Okay, so I'm just going to write in that this was my given. What might be a good idea for me to do on my picture? I think it would be a good idea for me to mark my picture that those are a right angle. Okay, so if I say PQR is a right angle, what gives me the right to say the measure of PQR is 90 degrees? It's erasing your hand now. Is that what you were going to say? Definition of a right angle. Okay. Okay. What's happening in number 3? What? Segment?
Oh.
Okay. I just want to make sure everything was okay. I think we just have a student having a little bit of a meltdown. Okay. So then what happens from step 3 to step 4? Okay, we know that PQR is 90, so we substitute, okay? Excellent. Yep. Yes. Mackenzie W. Okay.
Wait, that's Mackenzie W.
Okay. So here I have that these two add to 90. And then I say, hey, these two are complementary. What would that be? Definition of complementary. Okay, this would be like, say we're talking about like a test. We're talking about a test and I'm giving you a proof to do start to finish, like with blank statements and blank reasons. This would be a level of proof that I think that I could expect you to do by yourself on a test in 6 days. Okay, in 6 days.
Weekend.
Yeah.
You don't study on the weekends.
And then it's like 3 school days.
Look, guys, I'm giving you 2 days of angle proofs, 2 days of review, and then the test. And if you play your cards right, we will go outside either Monday or Tuesday to do our math.
Wait, yay! Wait, outside?
Yeah.
In outdoors? Oh, no, look at.
Oh, you play basketball?
No, we'll write proofs outside.
Touch grass.
Just a change of scenery.
Do not complain.
I got excited.
All right.
5 minutes total. Like to get in my car and get out.
All right, people. Angle 2 is congruent to angle 3, and angle 1 and angle 2 form a linear pair. Okay. Now, how many pieces of given information did we receive? 2, which means we can create 2 steps, one from each of those. Okay. We don't have to do them like all at once, but what is something that we can write from this right here? Okay, we know that the measure of angle 2 equals the measure of angle 3 because, like Braden said, definition of congruence. Okay. What about 1 and 2 are a linear pair? Okay, so what we can do is we can go straight from we have a linear pair to, okay, you're telling me they're supplementary. So the measure of angle 1 plus the measure of angle 2 equals 180 degrees. Okay. So technically this is called the supplemental theorem, or the supplement theorem, excuse me. But I am worried about you remembering that. And honestly, we learned linear pair as a definition. So this is me telling you, I'm okay with you saying that this is definition of a linear pair. And I just think that that will be easier for you to remember. And I think that the logic makes more sense there with the reason. Are you okay with it?
So instead of
Okay. All right. So now we eventually want to say that angle 1 and angle 3 are supplementary. So what can we do next? Oh, dang it. Yeah. So we can say, hey, angle 2 is really the same as the measure of angle 3. Right? We know that angle 2 and angle 3 have the same measure. So we can substitute angle 3 in for angle 2. Right? Hey, I have 2 angles that add up to be 180 degrees. No. So we know that angle 1 and angle 3 are supplementary because of the definition of supplementary. Linear pair means 2 angles are adjacent and supplementary.
Wait. Yeah, okay. Wait. What do you have to do before we get that?
No, because we're not talking about anything being equal. We're talking about two angles being supplementary.
No.
Okay, we're gonna take a break. We will come back to number 3. Okay, I want you to look at this. So basically, we're gonna look at a statement based on, you don't have it. You don't have it. Okay. If I'm gonna use the definition of congruence, I have a step that angle D is congruent to angle E. Do you agree with Clark?
Yes.
Okay. If I have the measure of angle 1 plus the measure of angle 2 is 90 degrees, then, yep. Because the definition of complementary angles. Okay. What about angle P and angle Q are supplementaries? Then are you okay, Alex? Or not Alex, Sam?
Yeah.
Okay. Okay, what about this one? If measure of angle JKL is 90 degrees, then
Is it right?
you guys are great. Great. Okay. If angle 3 and angle 4 are vertical angles, then nope. If angle 3 and angle 4 are vertical, what do we know about them? Well, they're congruent. They're the same measure. Okay. Do you remember what vertical angles look like?
Like
two never touch. Yeah.
Number 1 and number 2.
Number 1, number 2. What?
Yeah.
What?
That's one.
What did you say?
Wait, like if one's on the top and one's on the bottom,
And 2,
they're
4.
on the sides.
Yeah. But what did you say about numbers?
No, I,
Sometimes the angles are numbered.
yeah, it's like 1, 2, 3, 4. And then
You're
1 and 3.
Yeah, I'm right now. I'm nerd.
that was rude.
I know him like that. So.
No.
I mean, isn't everyone slightly smarter? Let him stop.
Okay. I am gonna give you a few minutes to at your table see if you can come up with a proof for number 3. I really think you can do it.
Angle 1 and angle 2.
18.
Right angle, that's a lot of ones. Right angle. I don't. We should get a bigger box.
This would be definition. Right angle. Right.
I don't have enough space for that. Can I just like draw it?
Drawn it, that's fine.
Equals 90.
There's no space, Brayden. That'd be good.
One and 2.
Wait, do we have to do the definition of congruent?
Oh, there you go.
Never mind.
Definition of what? Wait, if we did definition of congruence and they would change the measure. And then.
So, I only have 2 sections. We're on the second step.
The second one, okay.
So 1 and 2. 1 and 3. I already know this.
You can never or assume?
Form right angle, would that be definition? And then right angle. If one is both, two and three. Oh, that's one.
What are you talking about?
Oh, wait, I don't know.
Okay, okay, so, no, just think about it, okay, let's,
Remember how in the earlier
Okay, guys, we're good with something?
the mixture of angle one. Yeah, it's like the other thing. So what says the three? When two form right angle. And say. Say that angle one and angle three are equal to angle. Seven equals.
Because.
Well, no, can you just substitute?
Three equals measure of substitute, measure of angle two for measure of angle three.
Yeah.
go compare answers.
Or, no,
Yeah, I'm not gonna do that. I'm gonna say
Are you sure? Because they both use the measure of angle one plus the measure.
and then vote right.
Yeah. Because 1 and 3,
I just don't know.
and 1 and 2.
Okay, so, yeah, but that means that both ones. Wouldn't that be definitely?
What do you think both ones equal something else? If the measure of angle one plus the measure of angle three.
You're there for 5 steps. That's what you got.
The measure of angle two plus the measure of angle one would be the same thing.
I don't like the ones that are so obvious. To make ones that aren't.
This is too obvious for you?
No,
I don't even know how to
no,
spell it. I
like,
know
no,
it's
like the
right.
ones where you look at the given one and the proved one, and it's just like,
Okay, so Sam, can you verbalize just to me, why does it make sense that 2 and 3 would be the same?
well, I don't know how to do it, but like, if
Just talk about it.
if 1 plus 2 is 90
Okay.
and 1 plus 3 is 90, then 2 and 3 are the same, but like I don't know how to do that.
Okay.
I
So how do you know that 1 plus 2 is 90?
That was my problem with the test. Oh,
Okay.
because they're right angles,
Okay,
so they're 90.
okay. So you know that the measure of angle 1 plus the measure of angle 2 equals 90 degrees. You know that, because why?
Because it says that.
For right angle, right angle.
Okay. This is that complement theorem. Okay. If you said like, I'd probably take it. Okay. It's fine. Make it complement theorem. Okay. Now, if we have that the measure of angle 1 plus the measure of angle 3 equals 90, and the measure of angle 1 plus the measure of angle 2 equals 90, Sam, what can we do?
Can you substitute?
Okay, so they both equal 90, right?
Yeah.
So I can take the measure of angle 1 plus the measure of angle 2, 8 equals 90. So the measure of angle 1 plus the measure of angle 3, since it also equals 90, I can say that they're equal.
Oh, that's.
Yeah, what is
That's not subtraction property. So you could say transitive and be good. If you say substitute, I would take it also. Okay. Then what do you do? Since both of them have measure of angle 1, then we can subtract. Yeah. Sam, you did it. Yeah. All right. So here's the fun thing about today's homework. You have a page that's all algebra and a page that's proof. I'm sorry, would you like 2 pages of proofs?
Just great.
Okay. So page 22 and 23 are your homework. Page 22, it's all algebra. You're welcome.
Wait, 21 and 22.
Oh my gosh, do you listen?
I heard 22 is algebra.
But where did 21 come from?
Relearn
Cause it's on the same.